My dear students, in this video, I am going to define vector product or cross product of two vectors. So far we have seen dot product of two vectors or scalar product of two vectors. Dot product is nothing but a scalar product because dot product gives you a scalar quantity. That's why it is called scalar product. Now in this video, we are going to see vector product or cross product of two vectors A and B. Let OA is vector A and OB is vector B. Then A cross B. Vector product is defined by cross notation A cross B. Vector product of A and B is A cross B equal to modulus of vector A into modulus of vector B into sine of the angle between the vectors A and B, sine theta, into n cap, where n cap is a unit vector perpendicular to both A vector and B vector. Like that. Suppose A and B are acting in the plane. A and B are acting in the plane, then n cap is a unit vector acting perpendicular to both A and B. And minus n cap is also in the downward direction it is minus n cap, upward it is n cap. So A cross B is acting in the plane in my forehand. This is A and B are acting in the plane and n cap is the unit vector perpendicular to both A and B. And all these three vectors A and B form a right-handed screw system, right-handed system. Okay, if you rotate like this, n cap is moving upward. Similarly, moving downward, minus n cap is moving downward. So n cap is perpendicular to both A and B. So definition of A cross B is modulus of vector A into modulus of vector B into sine of the angle between A and B. Whereas in the dot product, cos of angle between A and B is defined. A dot B is mod A mod B into cos theta only. But vector product is mod A and mod B into sin theta into n cap, and n cap is a unit vector perpendicular to both A and B. That's why this A cross B is called vector quantity. So, theta is the angle between both A and B. Theta is the angle between the vectors vectors. Theta is the angle between the vectors A and B, and n cap is the unit vector perpendicular to both the vectors A and B. This is the definition of A cross B. A cross B is modulus of A into modulus of B into sin theta into n cap, and n cap is a unit vector perpendicular to both A and B, and theta is the angle between the vectors A and B, n cap. Okay? And this, suppose B cross A, if you point B cross A, theta is described in this direction, this is minus theta. So B cross A equal to mod of A or mod of B into mod of A into sine of minus theta into n cap. It is minus of mod A into mod B into sine of minus theta is minus sin theta into n cap. So this is minus of A cross B. So A cross B, but B cross A is minus of A cross B. That's why we define that A cross B is not equal to B cross A, because B cross A is minus of A cross B. If you interchange the cross product, it will become the sign of the product is changed. Also, note vector product is a vector quantity. Note cross product. Cross product is a vector quantity. Vector quantity. Example, force of a force acting by a particle, that is, this is acceleration, velocity, force, these are the vector quantity. Okay. So cross product gives the vector quantity. Properties of, okay, now properties of vector product. First property is dot product is not commutative because A cross B is not equal to theta A. It is, sorry, cross product. Cross product is not commutative. This is your first property. This is our first property. Okay? Next, we will see the properties of vector product. Properties of vector product. The first property is vector product is not commutative. So far I have explained that cross product is not commutative. That is, A cross B is not equal to B cross A. If the direction of vector is changed, B cross A is equal to minus A cross B. Okay, that's why cross product is not commutative. A cross B is not equal to B cross A. Whereas dot product is commutative. A dot B equal to B dot A. Dot product is commutative, whereas cross product is not commutative. A cross B is not equal to B cross A. Okay, second one. Vector product of collinear or parallel vectors. Collinear or parallel. If two vectors A and B are collinear, the two vectors A and B is coincident with A and B are collinear. In this case, theta equal to 0 degree. If A and B are collinear, acting on the same line. Parallel. In this case, parallel is angle between the two vectors. If it is in the opposite direction, theta is 0 or theta is pi. A, B. Theta is 0 or theta is pi. Collinear. Parallel is also, if the two vectors are parallel, there is no angle between the vectors A and B. In this case also theta is 0. The two vectors are parallel. In this case also there is no theta. In this case also theta equal to 0 degree. If the two vectors are collinear or parallel, theta is 0 or pi. In this case, sin 0 equal to sin pi equal to 0. Therefore, A cross B equal to mod of A into mod of B into sin 0 or pi into n cap. Whatever it may be, sin 0 is 0, therefore everything is 0, this is 0 vector. Since it is a vector quantity, A cross B is 0. The 0 vector. So if the two vectors are parallel or collinear, A cross B is 0. 0 vector. From this I can get two conditions. So the three conditions. If the two vectors are collinear or parallel, first one is either A vector is 0 vector and B is any vector, and B is any vector. It is an idea. Second one is B vector is 0 vector and A is any vector, and A vector is any vector. Either B is 0 or A is 0. B vector is 0 and A is any vector. Three cases are arising when A cross B, A and B are collinear or parallel. We get A cross B is 0, otherwise either A is 0 or B is any vector, or B is 0 and A is any vector. Third one is A and B are collinear or parallel. A and B are collinear, or A cross B is 0, or collinear or parallel. So this condition is if A cross B equal to 0 vector, if and only if, to imply, if and only if A, B are collinear or parallel. A and B are collinear or parallel. This is the idea of collinearity of two vectors. If and only if, to implied, if A and B are collinear or parallel, A cross B is 0. If A cross B is 0, A and B are collinear or parallel. Whereas in the case of dot product, A dot B is 0 implies A and B are perpendicular. That is the difference between dot and cross product. Okay? Next, another property, third property, cross product of equal vectors. That is A vector cross A vector. Two vectors are equal. By definition, A vector A cross A is mod of A into modulus of vector A into, since it is a same vector, no theta, so sin 0 only, n cap unit vector perpendicular to both A and A, that is sin 0 is 0, therefore this is 0 vector. So cross product of equal vectors is A cross A is 0. Whereas the dot product A dot A is A square. Remember, comparing dot and cross side by side, A cross A is 0 vector, whereas A dot A is A square, dot product. Now fourth one is cross product of I, J, K unit vectors, mutually perpendicular unit vectors. Cross product of I, J and K, mutually perpendicular unit vectors. Mutually perpendicular unit vectors. So you know coordinate system. This is OX axis, OY and OZ. These are three mutually perpendicular coordinate systems. Axis in the space. In x-axis you get I cap vector, y-axis you get j cap vector, and z-axis you get k cap vector. I, j, k are unit vectors which are mutually perpendicular, acting along the mutually perpendicular coordinate axis OX, OY, OZ. Okay. See, we have to find out I cross J, J cross K and K cross I. In the anti-clockwise direction, we have to find out first. I cross J, I cap cross J cap. I cross J is mod of I into mod of J into angle between I and J is 90 degree because they are mutually perpendicular. You will get sin pi by 2. Sin I into perpendicular unit vector perpendicular to both I and J is K. K is the unit vector perpendicular to both I and J. Therefore, this is K cap. You get mod of I is 1, mod of J is 1, sin 90 is 1. You get K cap only. So I cross J is K. That's our result. I cross J is K. Similarly, J cross K is I. J cross K is I. And K cross I. K cross I is J. So I cross J, K cap, J cross K, I cap, K cross I, J cap. So this is the mutually perpendicular cross product of mutually perpendicular unit vectors, and also reverse direction J cross I. J cross I is minus K, and K cross J. K cross J is minus I. Similarly, I cross K minus J. If it is in the clockwise direction, the sign will be changed. So I cross J, K, whereas J cross I minus K. J cross K is I vector, I cap, where K cross J is minus I, like that. Same vector, cross product of equal vectors. In this case, I cross I cross I, that is equal to mod I into mod I into sine 0, because angle between I vector is 0, and n cap. I vector perpendicular is, you can call J is the unit vector perpendicular to I, but sine 0 is 0, therefore everything is 0. So I cross J is 0 vector. I dot I is 1. I dot J is 0 in the dot product case. Here, same vector is 0. Cross product of same vector is 0. I cross J, I cross I, sorry. I cross I is 0. Similarly, J cross J is 0 vector, and K cross K. K cross K is also 0 vector. So same vectors are 0. Other vector cross product is the next vector. Clockwise sense you will get positive vectors, anti-clockwise sense you get positive vectors, clockwise sense you get negative vectors. So I cross I 0, J cross J 0, K cross K 0, equal vectors is 0 already we have seen. These are the cross product of I, J, K unit vectors. Okay. Next property, number 5. If M is any scalar, if M is any scalar and A, B are any two vectors inclined at angle theta, and A, B or any two vectors then M into A cross B. So M into A cross B equal to MA cross B or A cross MP. So the scalar M can be associated either with A or with B or A cross B. So this one property. M is any scalar, M into A cross B is MA cross B or A cross MB. Next property, vector product is distributive over addition. Vector product is distributive over addition. Vector product is distributive over addition. For that, you consider any three vectors A cross B plus C, A, B, C or any three vectors, A cross B plus C equal to A cross B plus A cross C. A cross B plus C equal to A cross B plus A cross C. Another one, B plus C cross A. This is left distributive. Second one is right distributive. B cross A plus C cross A. So first one is left distributive. Left distributive law. Second one is right distributive. Right side A. Right distributive law. Okay. These are the two properties for vector product is distributive organization. Left distributive and right distributive. Okay. I will stop my video here and I will continue the cross product ideas in my next video. Thank you.